Alright, so let's take a look. The first page is mostly just vocab. So the standard form of a quadratic is, what do you think? Perfect. Ax squared plus bx plus c. This is our standard form. The shape of a quadratic equation is called a what? A parabola. This little dotted line down the middle is what? Axis of symmetry. Oh, the little dot at the center down low here. What's that? This point. The vertex, perfect. When the vertex is at the highest point on the graph, we call that a maximum. When the vertex is the lowest point on the graph, minimum. Our solutions are called the but this would be x-intercepts. And then this would be zeros / roots. All right. So for the next little part, it says determine whether the quadratic functions have 2 real roots, 1 real root, or no real roots. If possible, list the zeros of the function. So our zeros are where it crosses the x-axis, our intercepts. So how many roots do we have here for number 9? How many places do we cross the x-axis? 1, just right here. So we have 1 root, and what is that? So this is 0, x would be 1, 2, 3. It's kind of hard to see. So x equals 3. For number 10, how many roots do we have? 0. Awesome. We don't touch the x-axis here, so we have no roots. For number 11, how many roots do we have? 2. And what are those? Awesome. Good job. All right, let's look at number 12. So we're given the graph, identify the following. First, our axis of symmetry. What would our axis of symmetry be? So axis of symmetry goes right through the center of our graph here. 3. So x is equal to 3 because it's a line and it goes through x at 3. What's our vertex? Perfect. 3, -2. How many zeros do we have? 2. And what are our zeros? X equals 2 and 4. What's our domain here? Awesome. All real numbers. Domain of all parabolas that open up or down are all real numbers. And what's our range? So remember, range is y values. Perfect. We start with our smallest y value, so that would be -2. And then it goes up forever, so -2 to infinity. All right, sometimes it's just going to give you the equation in standard form and ask you to find the axis of symmetry, vertex, domain, range, all that fun stuff. So to find the axis of symmetry, we use this formula. X is equal to negative b over 2a, where b comes from our middle term, the number in front of the middle term, a comes from the number in front of the x squared. So looking at 13, negative b over 2a, what is our a? So remember, 1, perfect. A is in front of the x squared. And what's our b? Negative 2. So we just plug that into our axis of symmetry formula. So we have negative 2 over 2 times 1. So this would be 2 over 2. So what's our axis of symmetry? X is equal to 1. Now our vertex is always on the axis of symmetry, so it's always going to have the same x value. And then to find what the y value is of our vertex, we just plug in x and solve for y. So we're going to plug in 1 to our equation here and solve for y. So we have y is equal to 1 squared minus 2 times 1 minus 3. So 1 squared is 1, minus 2 minus 3. So this would be what? Negative 4. So the y of our vertex is negative 4. So we can go ahead and put those on our graph. We're going to go to the right 1 and down 4. And our axis of symmetry goes right through it. So now we need to identify the zeros or roots. How can we find the zeros? To find the zeros, we set y equal to 0 because we're finding the x-intercepts. Those are our zeros. So change y to 0, x squared minus 2x minus 3, and then we solve by factoring. So do we have two factors of negative 3 that add to negative 2? Negative 3 and 1. So x minus 3, x plus 1. So what are our zeros? Awesome, 3 and negative 1. So we're going to cross the x-axis at 3 and negative 1. So we can go ahead and put those points on our graph. We go to the right 3 and go to the left negative 1. Once we have our 3 points, we can draw our parabola. And then let's see what other questions can we answer. Does it have a minimum or maximum? It has a minimum. What is our y-intercept? How can we find the y-intercept? Set x equal to 0. So y is equal to 0 squared minus 2x minus 3. So this should be 0. Y is equal to negative 3. Your y-intercept, whenever you're in standard form, is always just going to be this number, your c. That's always your y-intercept. Because when you plug in 0 for x, it's just 0, minus 0, or plus 0. And then you're just left with whatever that third number is. So our y-intercept is negative 3. What's our domain? All real numbers. And what's our range? Perfect. Negative 4 to infinity. And then it says graph at least 5 points. We can put our y-intercept on here. So negative 3 And then since we're one space away from our axis of symmetry on the left side, we need the same space on the right side of our axis of symmetry, so we would just be one space away on the right side also. So those are our 5 points. Any questions here? So here it asks us to find two quadratic functions, one that opens upward, one that opens downward, whose graph have the given x-intercepts. There are many correct answers. So to do these types of questions, it gives us our two x-intercepts. So x is equal to -1 and x is equal to 3. We work backwards to find what our equation would be. So to get our x-intercepts, we factor it, and then we set each equal to 0. So to work backwards, this would be x plus 1, and this would be x minus 3. Everybody sees how we got that? All right. And then from here, you would just FOIL it out. So multiply the first ones, x squared, the outsides minus 3x, the insides plus x, and then the last. So x squared minus 2x minus 3. This is one equation. It asks us to find two. This, our x is positive, so it opens up. We can multiply everything here by a negative number to get one that opens down. So we would have y is equal to -x squared plus 2x plus 3. So these are our two equations. Any questions here? Super. For 19 and 20, write the equation of the quadratic in standard form from the graph below. We zero, three. 0, 3, because we stay on 0 and go up 3. So 0 is our h, 3 is our k. And then we can pick any other point on our graph here to use as our x and y, and we solve for a. So any point on this graph, preferably one that goes through two whole numbers. So I'm going to pick 1, 4. And use that as my x and y. I'm going to plug h, k, x, and y into my equation up here to solve for a. So f of x is just a fancy way of saying y, so I'm going to plug y in there. 4 is equal to a times x, so 1 minus h is 0, squared plus k, which is 3. And I just solve for a. So 1 minus 0 is 1. 1 squared is still just 1. 1 times a is just a. So 4 is equal to a plus 3. What should I do next? Subtract 3. So 1 is equal to a. And then I can just take h, k, and a and plug it back in. So I have f of x is equal to, a is 1, so you can write it or not, x minus h, so just x squared plus k, which is 3. So it would just be f of x is equal to x squared plus 3.